7 ISCE. It's called as integers. So what are integers? Let's draw a basic number line starting from 0, 1, 2, 3 and 4, and the same goes for behind. It gets minus 1, minus 2, minus 3 and minus 4. All numbers starting from 1 to up to infinity are known as natural numbers, and numbers starting from 0, 1, 2, 3 up to infinity are known as whole numbers. Integers are nothing but all numbers encasing from the negative infinity till the positive infinity. And you have to keep in mind that integers do not include fractions. Integers do not include fractions. And in this chapter, we're going to see the basic rules of addition, subtraction, multiplication, and division of two or more integers. Property of addition. In this subdivision, let us see how two integers are added. In computative properties of addition, the formula states that a plus b is equals to b plus a. Let's look at an example for this. Let us take two integers. For example, a is equal to 5 and b is equal to 7. Let us substitute a is 5 and b is 7 in both these equations. You get 5 plus 7 is equal to 7 plus 5. 5 plus 7 is 12. 7 plus 5 is 12. Therefore, hence proof. Commutative property says that a plus b is equal to b plus a, which means that whatever order you may add these integers, the answer is going to be the same. The next solution, we will look at associative properties of integers. Associative properties. In this properties, the formula states that a plus b plus c is equal to a plus the bracket of b plus c. It states that when you add two integers first and then you add a third integer, the answer does not refrain or deviate from the fact that if you add b plus c first and then add a to it. Let us take another example for this equation. Let us take a is equal to 1, b is equal to 3, and c is equal to 5. If you substitute all these values, you get 1 plus 3 plus 5 equals 1 plus the bracket of 3 plus 5. And we already know by Bohr's rule that whatever comes in the bracket first should be simplified first. So 1 plus 3 is 4 and 4 plus 5 is 9. And the same for the right hand side, it gets 1 plus 5 plus 3 is 8, so 8 plus 1 is 9. The next subdivision is called as closure property of subtraction of integers. Closure property. This axiom states that if a is an integer and b is also an integer, the answer of a minus b is also an integer. For example, if you take a as 5 and b is 2, 5 minus 2 gives you 3, which is also an integer. Before we have seen that addition is associative as well as commutative. And the next thing is in subtraction is neither commutative nor associative. For example, in this equation, subtraction is not commutative. And what I mean by this is a minus b is not equal to b minus a. When you change the orders of the integers while subtracting two numbers, the answer becomes really different. Let us take an example. A is equal to 7 and b is equal to minus 3. Now let us substitute these numbers in the formulas and we get 7 minus, and please only know the minus between a and b, minus of minus 3 because there's already a minus symbol before 3, which equals to, what is b? b is minus 3 and minus of 7. So for the answer for this is 7 minus into minus, minus a into minus a, gives plus a. Plus a. Minus into minus gives you plus. Therefore minus into minus is plus. So the answer is 7 plus 3. On the right hand side, it becomes, because both the symbols are at minus, you add and you write minus symbol. So therefore, the answer on the right hand side becomes minus 10. 7 plus 3 is 10. Minus 3 minus 7 is minus 3. Therefore, the answers are not same. And therefore, you can prove that subtraction is not commutative. Subtraction is neither associative. Okay. In this, same as before, we saw that addition was associative. By that I mean that a plus b plus c was equal to a plus b plus c. But in this subtraction, you can't use the same axiom in subtraction, because in subtraction, a minus b minus c does not equal to a minus b minus c. Let us take another example for this one. Let us take a is 2, b is 5, and c is minus 3. Let us substitute these numbers in this equation. So a becomes 2 minus 5. Minus of minus c is plus c. So we get plus 3, which is equal to a is 2 minus of b is 5 minus of minus c is plus 3. Okay. So because there is a minus here, you have to multiply minus into minus and you get plus 3. 2 minus 5 is minus 3 because 5 is the greater number and it has the negative sign. So you solve the bracket first according to Bohr's rule and you get 2 minus 5 as minus 3. And next it's plus 3, which is equal to 2 minus 5 plus 3 is 8. You can further remove the brackets and you get minus 3 plus 3 equals 2 minus 8. Minus 3 plus 3 gives you 0 because it's the same number with the opposite symbols. You can cancel out and write 0. 2 minus 8 is minus 6 because 8 is a larger number and has a negative value. And you can clearly see that the answers are not the same. Therefore, subtraction is neither a satisfying sum of integers 58 minus 236 minus 58 minus 64 and minus 200. And the first step of solving this sum is to write them in an equation. 58, and please make sure that you write the symbols, appropriate symbols before each integer. 64 and minus 200. And looking at this question, you can see that 58 and minus 58 are in common, so it will be easier for you to find the answer if you group these two terms together. So 58 and minus 58, and then you can group the latter terms as minus 236, minus 200 and minus 64. 58 minus 58 is 0, so you can write 0 here. Minus 236 and minus 200 and minus 64. Since all the symbols are negative, what you have to do is you have to add all the values and write minus symbol in the front. So 236 plus 64 gives you 236 plus 64 gives you 300, which is minus 300 minus 200 because we haven't evaluated this. So the answer is minus. Now we have to get multiplication of integers. In multiplication of integers, there's something called the closure property. Same as I've seen in addition. Closure property is nothing but when a and b are both integers, and if you multiply both of them together, the answer you get is also an integer. And just like addition, multiplication is also associative and it's also commutative. Let us look at the commutative property of addition or multiplication. Commutative property. In commutative property, they say that a into b is equal to b into a. This axiom proves that. The axiom states that a multiplied by b gives you b multiplied is equal to the value of b multiplied by a, no matter what the value of the integer is. We can take two examples for this. Let us take a as 2 and b as 3. If we take a as 2 and b as 3, we get 2 into 3 and 3 into 2, which is equal to 6 is equal to 6. Therefore, the commutative property is hence. Let us look at the associative property. And just like addition, multiplication also shows associative property, where A into B into C is equal to A times bracket of and distributive law of multiplication. The first subdivision is distributive law of addition. In this law, it states that when A is multiplied to B plus C, the answer is first you have to multiply A with B and then you multiply A with C, which gives you A times B plus A times C. Therefore, this is the distributive law of addition. The same goes with distributive law of subtraction, in which A is multiplied with B minus C. So you get first you multiply A with B, then you multiply A with negative of C. So the answer you get is A times B and minus. Let us look at a sum before going to the next subtraction. In the sum, they want you to multiply minus 20 with minus 2 with minus 5 and minus 7. All these numbers are integers in which the first three numbers are negative. So the easiest way to do this is, 5 into 2 is 10. So first you can solve that. You can take them in a separate bracket. You can write minus 2 into minus 5 into minus 7. We know that negative into negative gives you positive and 5 into 2 is 10. So therefore, you can further simplify it as minus into minus is plus and 5 into 2 is 10. Therefore, you get minus 20 into 10 into 7. And we know that minus 20 into 10 is minus 200 because minus A into B gives you minus of A into B. When one is negative and one is positive, the answer is negative. Therefore, minus 20 into 10 is minus 200. And you still have, and minus 200 into 7 is minus 1400 because there's a minus here. And minus into plus is negative. So the answer is division of two integers. Division is not closed unlike like multiplication, addition, and subtraction, because when you divide two numbers, let us say A is equal to 12 and B is equal to 4. When you divide A by B, you get 12 by 4, which is 12 goes 3 times, so the answer is 3. But if you take B by A, the answer becomes 4 by 12, the answer becomes 1 by 3, which is not an integer. So this proves that division is not commutative. Next, we're going to see that division, what happens when we divide a number with a negative number. So example, let us take B as minus 4. You get 12 by minus 4. Same like multiplication, where you multiply plus and minus, you get a negative number. The same goes with division. When you divide 12 with a negative of 4, you get the same answer, but just in negative.